This is Module 6, Lesson 10, Concept Development. We are going to start out by looking at our rule, y is 0 more than x. And you know what? Just before we get started here, I did grab some colored pencils. I did grab 4 different colors. I grabbed a blue, a green, a red, and an orange. If you want to do that, you can as well, or just use a pencil, which is fine. It just helps me see the lines a little bit more clearly. So my question for you is, y is 0 more than x. What point on this line has an x coordinate of 3? On this line, what is the coordinate? What point on this line has an x coordinate of 3? Well, let's take a look. Well, do you know what we didn't do before we started? We didn't label our x-axis and our y-axis. Then we need to stop and figure out how our table is broken up. It looks like it's just broken up into whole numbers. 1, 2, 3, 4, 6, 7, 8, 9. Okay, 1, 2, 3, 4, 6, 7, 8, 9. Okay, it's broken up by whole numbers. So we know what we're dealing with now. All right, so now, what point on this line has an x-coordinate of 3? Well, an x-coordinate of 3. So, 1, 2, 3, 3. So that would be 3 and 1, 2, 3, right? That would be 3, 3. So what I want you to do right now, I want you to go up here to y is 0 more than x. Y is 0 more than x. Go ahead and fill out your y coordinates and fill in your coordinate points and come back and check your work. What does it mean? Y is 0 more than x. Is this what you got? 0, 5, 10, 15. So 0, 0, 5, 5, 10, 10, 15, 15. Now look, if you actually plot these points, 0, 0 at the origin. Oh, we forgot to label our origin. 0, 0, 5, 5, 10, 10, 15, 15. And that is line P. Can you find another way to name the rule for line P? So y is 0 more than x. What's another way you could say that? Well, you could also say y is equal to x. Y is equal to x. Could it be y is x times 1? Y is x times 1. That would be another way to say y is 0 more than x. So there are different ways to name or different rules to call something, or this line has different rules that it could be called. So go ahead and plot your points and use your straight edge to construct line P. And then as you're working on this, what do you notice about line P, whose rule is y is equal to x? What do you notice about it? Well, it passes right through the origin and right through the entire plane. It cuts the plane into 2 pieces, right? All right. Do me a favor. I want you to now plot point 13, 18. Go ahead and plot point 13, 11, 12, 13, and 18. 16, 17, 18. Now, on the coordinate plane here, on this coordinate plane, use your straight edge and set or something like your straight edge or your set square to construct line B so that it is parallel to line P and contains point B. Oh, we're going to name this point B. So you are going to construct a line that is going to cut through point B, but is parallel to P. Go ahead and try that and come on back. Okay, so what did you come up with? So I went ahead and tried to figure out what rule I could follow in order to plot the points. What did you do? Well, some of you may have noticed that when X was 10, Y was 15. And when X was 13, Y was 18. Oh, I see a pattern. It's increasing by 5. Oh, wait a minute. Is that what this is right here? Go ahead and fill out your chart and go back and check your points. Do they match up? Did you see that pattern? If you didn't, first figure out what your y coordinate is, figure out your coordinate points, plot your points, and draw your line. And we are going to name this line B. All right. Did you get 7 and 12, 10 and 15, 13, 18, 18 and 23? What pattern do you notice in the coordinate pairs for line B? Every y coordinate is 5 more than the x coordinate. So if I have 5, if I add 5 to every x coordinate, I get the y value. So our rule, y is 5 more than x, or x plus 5 is y. You can also say x plus 5 equals y. Since every y coordinate is 5 more than the x coordinate, the rule for line B is y is 5 more than x. So look at our rule for line C and line D. We're going to use the rule y is 10 more than x. So go ahead and figure out what your y coordinate is and figure out what your coordinate points are and plot that. Okay, so did you get y is 10 more than x? Did you get 2, 12, 4, 14, 8, 18, 11, and 21? 2, 12, 14, 4, 14, 8, 18, 11, 21. Did you plot your points and label it line C? Finally, let's go to y is 3 less than x. So wait a minute. Line B and C. Wait a minute. This was supposed to be line B. This is line. No, A, P. Yeah, I was right in the beginning. Line P, B, C. All right. So line P, y is 0 more than x. Y is 5 more than x. Y is 10 more than x. So line B and C, notice they're parallel to line P, but they increase, right? This one isn't, this is just 0. This is just cut straight in half, line P. But y increased by 5 more. The y coordinate increased by 5. And on line C, the line increased by 10 in comparison to P. So what do you predict the line D is going to do when y is 3 less than x? So y is going to be 3 less than x. Well, what is the difference in the rules that we're using? Y is 5 more. y is 10 more. So this line B was using addition. Line C was using addition. And now line D is using what? What are you using in order to solve? You are going to use subtraction. So if this is increasing, what do you predict line D is going to do? Is it going to be above P or below P? Let's find out. Plot the points. So did you predict that line D would be below P? I had a feeling you did because you noticed the pattern, and that's what we're picking up today. That's our big idea. It's compare the lines and patterns generated by rules, by addition rules and multiplication rules. Well, and then we have a subtraction rule. All right, so we plotted line D. Question for you though. Look again at the coordinate plane. Do any of our lines intersect? No. They are all parallel, right? They're parallel lines. They're all parallel. Lines C and B both have y coordinates that are greater than the ones for the same x coordinates on line P. It means they increased, the y coordinates increased. The y's on line B are all 5 more, and the y's on line C are all 10 more than y's on line P. So the rules in line C and B, what do they have in common? Well, we discussed that earlier. They're both addition rules. They both require us to add to the x coordinate, but line C is adding more to the x coordinate than the B. So what about line D? What operation is used in the rule for line D? It's subtraction. And where does line D lie on the plane in relation to the other lines? All the points on line D are closer to the x-axis than the other lines, right? Line D is below the other lines on the plane. All right. So line P is the one that went straight up the middle. Okay, we've analyzed this plane well enough. So let's turn and look at the back side. So if you notice, there's a line P already here. It's the same as the line P on the other plane. It's the line for the rule y is equal to x is equal to y. This is the same line we drew on the other plane. It represents the rule y is equal to x, or we can also think of it as y is to x times 1. So on your plane, plot a point G at 3, 9. Go ahead and plot a point G at 3, 9, and show me what you get. Is that what you got? 3, 9. Right here. All right. So now I want you to use your straight edge or a ruler and draw a line G so that it passes through the origin. Oh, we did it again. We forgot to label our x-axis and our y-axis. We forgot to label our origin, and we forgot to make sure what the intervals of our plane were. So it looks like it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so it's by increments of 1 unit. So now you're going to take your straight edge and you're going to draw line G so that it passes through the origin passes through the origin and contains point G. Construct that line and come back and show me what you have. All right, did you get something that looks like this? Look at line G. What point on the line has an x-coordinate of 1? X-coordinate of 1 is 3. 1 and 3. Oh, x-coordinate of 3. 1, 2, 3, 3, and 9. All right. Fill in I'm going to give you the rule up here. Y is x times 3. Go ahead and fill in your your y coordinates and fill in your coordinate points. Plot your point, label it G. And make sure, see if your G with your actual coordinates matches up with the G that you drew with your ruler. Y is x times 3. Go ahead and go. All right, does it look like this? 3, 1, 3, 2, 6, 5, 15, 2, 21. 7, 21. If you plotted your points, did you get it? All right. What pattern do you see in the coordinate pairs for line G? Well, the y coordinate is always more than the x coordinate, yes. So if I multiply the x values by 3, I get the y coordinates. So I think the rule is definitely y multiply x by 3 to get y. So y is x times 3. So different ways to write that would be y is 3 times as much as x. Y is x times 3. Multiply x by 3 to equal y. Now, this line is much steeper than line P. Why is that? Why is this line much steeper than P? Do you remember the rule for P? The rule for P was y is 0 more than x. So the x and y coordinates were equal. Why is this one much steeper? Well, we're multiplying. So we're multiplying. When you multiply, you increase more quickly, right? Yes. All right. So now I want you to look at this rule for line H. Y is 1/3 as much as x. So 1/3. What do you predict at line H, where it's going to lie in the coordinate plane? It's only 1/3 as much as x. So do you think H is going to go up more gradually than the others, or do you think it's going to go up really steep? All right, go ahead, find out your y coordinates. Figure out what your coordinate points are and graph this. Come back and check your work. All right, so were you able to multiply x by 1/3, 3, 1, 6, 2, 12, 4, 15, 5. Now, if you notice, line H increases so much more gradually, and if you look at the y coordinates, they're only gradually going up. So H is less steep than the others. G is still the steepest, and line H is the least steep. So why do you think line G is the steepest and line H is the least steepest than the others? Well, they're both described as with multiplication rules, correct? However, line G's rule multiplies at a larger number than the rule for line H. But do you know what this reminds me of? This reminds me of the scaling work we did. Do you remember? So the rule for line G multiplies by a number greater than 1. Oh, do you remember that? When you multiply a number by a number greater than 1, your answer is always greater, correct? And if you multiply by a number less than 1, your answer is going to be less, right? So the line is really steep here because you're multiplying by 3. Line H multiplies by a number less than 1, so the line goes up more gradually, so the numbers are smaller. So imagine a line I whose rule is y is x times 2. Line I represents the y. The rule y is x times 2. Why does it make sense that line I would be steeper than line P, but not as steep as line G? It would be steeper. Why wouldn't multiplying by 2 be steeper than P? Well, for P, the x and y are equal. So if you have to multiply by 2, of course it's going to increase more drastically. So multiplying by 2 is more than multiplying by 1 and is less than multiplying by 3. It's kind of almost like measuring angles on a protractor. 60 degrees is between 45 degrees, right? And 80 degrees. So the line for multiplying by 2 should be in between the lines for multiplying by 1 and 3. Okay. So now that I got you thinking about that, going back to what you already know. With the line for the rule, if I said y is x times 1/10, be more steep or less steep than h? Well, it would be less steep because you're multiplying by a number less than 1/3. So line H would be steeper if we were multiplying by 1/10, because 1/10 would be smaller than 1/3. So the line for multiplying by 1/10 would go through the origin at the point 10, 10, 1, 10, 1, which would be way less steep than line H. So the line for the rule y is x times 1/10 would be the least steep of all the lines. So what I'm trying to remind you of is what you already know, multiplying by a number greater than 1. So you're doubling, you're tripling, you're quadrupling, you're quintupling, sextupling, septupling. So remember, that's scaling, and you learned all about that, I think, in module 1. So that's it for our concept development. Now you're going to go through and follow exactly like what we just did for the problem set. Here, there are 2 problems here. Oh yeah, this is easy. You can do this so easily. Here's your exit ticket, and then here is your homework for problem module 6 lesson 10. Great job, you guys.